Hello and welcome to day 7 of Advent of Code. Let me put that in here. So yeah, just made myself a nice cappuccino. I always love to have a cup of cappuccino with me. And yeah, let's start reading day 7. Let me pull up a second monitor to monitor chat. I was like, I'll set it 50 minutes in advance. That's plenty enough to do everything and get the coffee ready, and nope, my timing is off. So yeah, let's pull up the chat here so that I notice it when people say things. Okay, great. Hey Smap UK, welcome back. Nice to see you. Did you do, oh, of course you've done it already. Did you do yesterday's one? And if so, which approach did you take? I had some fun with yesterday's one. I don't have the code here because I wrote it, actually do I? I don't even know. I think I wrote it at home on my home PC, so I don't have the r/advent of code. Let's pull out that one. Let me see. I did a binary search after the fact because it was suggested yesterday, or I talked about it yesterday. So this is the binary search one, which is very fast. The only trick is that if you don't start off with a known hit, it can be a pain because you might not hit it right away. So I did some code yesterday to, I think, was it find match? I don't even remember. I wrote some code to incrementally grow the range that you search. Oh no, it was this one, I think. Yes. So basically what I did is, if you want to do a binary search but you don't have your reference value yet, I wrote this little function that will just take your search space and start off with like, okay, let's divide it in two. So look in the middle. And if you don't, divide it again and take 4 sample points. If you don't, so you make the search area smaller every time and do more samples. So what I did was I did this to find a hit, and then from there do a binary search, and I wrote all sorts of code. But in the end, I think you just need to do that, and for this search space, the hit is actually like the highest values in the middle, so you don't need it. But if you would do something like this on an unevenly distributed value, and that's why I coded up this, I set all sorts of tests with off-sync, off-balance versions, so that I know it would work. So this was fun to write, and it's very fast. And I just posted this to Reddit because yeah, I wasn't going to post the rest yet. So yeah. Let's see what Smap says. I did a binary chop first. I assumed he would make a solution that would boot first. Yeah, okay. Yeah, for me, the thing that I reasoned about, if I look at day 6, right? Not plus, day 6. If you look at these values, you can see a symmetric set of values. So 0, 6, 10, 12, 12, 10, 6, 0, right? So when I read that, I immediately had in my head, okay, it's like this. It's like this. So I figured I'll just start here, look until I encounter the first value, and then once I dip below it again, I don't even need to check out this. So that was the optimization that I did, because I was like, okay, that will save some time. But since it's such a basic search and the range was very small, I didn't look at it. If you look at my code, you can see what I did. Okay, let's do that before we start today's one. I only have 7,000 notifications on Discord, so that's always fun. So let's just do github.com. Solutions 23. Day. No, not day 7. Didn't see anything. Let's see. Wait for it. Ah, you also have the description in there. That's nice. So you have like a website where you display that probably. Mass. So for the quadratic formula, yeah. Funny. Brute force. Let's see. Binary chop. -1 marks time. Yes, well. Yeah, that's basically the same thing that I did. It's only like this won't, I think this won't work if the first thing that you hit isn't a match and you're not within the range. You can fizzle out. At least that's what I, so like if you have, but in this case, because of the way that the data works, that will never happen, so it's not an issue. Yeah. Let's go to day 7, Camel cards. Your all expenses paid trip turns out to be a one-way 5-minute ride in an airship. At least it's a cool airship. It drops you off at the edge of a vast desert and descends back to Island. Did you bring the parts? He asks. You turn around to see an elf completely covered in white clothing, wearing goggles and riding a large camel. Did you bring the parts? She asks again, louder this time. You aren't sure what parts she's looking for. You're here to figure out why the sand stopped. The parts for the sand! Yes! Come with me, I'll show you. And she beckons you onto the camel. After riding a bit across the sands of Desert Island, you can see what looks like a very large rock covering half of the horizon. The elf explains that the rocks are all along the part of Desert Island that is directly above Island, making it hard to even get there. Normally, they use big machines to move the rocks and filter the sand, but the machines have broken down because Island recently stopped receiving the parts they need to fix the machines. You've already assumed it'll be your job to figure out why the parts stopped when she asks if she can help. You agree automatically. Because the journey will take a few days, she offers to teach you the game of Camel cards. Okay. Camel cards is sort of similar to poker, except it's designed to be easier to play while riding a camel. That will come in handy. In Camel cards you get a list of hands, and your goal is to order them based on the strength of each hand. A hand consists of 5 cards, labeled one of AKQ, okay? So no, T for 10, okay. Okay, the relative strength of each card follows this order, where A is the highest and 2 is the lowest. Every hand is exactly one type, from strongest to weakest. They are 5 of a kind, 4 of a kind. Wait, what? Where 4 cards have the same label and 1 card has a different label. So why do they print it like AA, so that you can easily tell it's 4 of them? Okay, Full House, where 3 cards have the same label and the remaining 2 cards share a different label. 3 of a Kind, where 3 cards have the same label and the remaining 2 cards are each different from any other card in the hand. 2 Pair, where 2 cards share one label, 2 other cards share a second label, and the remaining card has a third label. Okay, 1 Pair, where 2 cards, okay. A High Card, where all cards' labels are distinct. Okay. Hands are primarily ordered based on type. For example, every Full House is stronger than any 3 of a kind. Sure. If 2 hands have the same type, the second ordering rule takes into effect. Start by comparing the first card in each hand. If these cards are different, the hand with the stronger first card is considered stronger. If the first card in each hand has the same label, however, then move on to considering the second card in each hand. If they differ, the hand with the highest second card wins. Otherwise, continue with the third card in each hand, and then the fourth, and then the fifth. Okay? So 3, 3, 3, 2, and 2 A are both 4 of a kind hands, but the first one is stronger because its first card is stronger. Okay. Similarly, 7, 7, 8, 8 and 7, 7, 7, 8, 8 are both a full house, but 7, 7, 8, 8 is stronger because its third card is stronger. Okay. And both cards have the same first and second card. Okay. To play Camel cards, you are given a list of hands and their corresponding bid, your puzzle inputs. For example, this example shows 5 hands. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1, the second weakest hand gets rank 2, and so on up to the strongest hand. Because there are 5 hands in this example, the strongest hand will have rank 5 and its bid will be multiplied by 5. So, the first step is to put the hands in order of strength. Okay, is the only one pair, and the other hands are all stronger, so it gets rank 1. Okay. Are both 2 pair, the first cards both have the same label, but the second card of that is stronger. Okay. Okay. So both 3 of a kind. Yeah, okay, that makes sense. And so it gets rank 5. Okay. Now you can determine the total winnings of this set of hands by adding up the results of multiplying each hand's bid with its rank. Okay. So you get 75. Okay, that was the 1 pair one, right? Okay. So the total winnings in this example are that much. Find the rank of every hand in your set. What are the total winnings? Okay. A lot to take in. Jesus. And these are a lot of hands. Okay. So what we need to do is a way to parse this and evaluate that into hands. Okay. It's a lot of work, I think, but it will be fine. Day 7. Day 7. Set up the base class and we do input with this. Okay. Let me think, because we need to do a bunch of stuff. So we need to have like the card strength. Let's make a mapping for that. Card map is new. And now we can do, so we have A, and let's go from the bottom actually. So 2 is 1. 3, 4, 5, 6, 7, 8, 9. T, J, Q, K, A, right? K, A. 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. Okay, so that's our cards mapped so that we can order it by that. That is fine. Public class hand. It's actually 5 card hand. Public char. How do we do this? We can just make this a char array. Cards. Like this. public 5 card constructor here. And we also have a strength public long. Do I actually need a long? Probably not, right? I mean, the power in the end will go crazy. This is actually a short, but yeah, it's fine. Public, I'll just do an int power. I'm probably coding in front of the camera screen. I need to take account for that. And let's also zoom in the code a bit. So yeah, we have that. Yeah, sure. So we need to have a card rank as well. So we have a public byte and rank. We'll figure that out in a bit. So the string rar. We'll have a public 5 card hand, and we'll take a yes char array cards int power like this, and we can do if cards of length throw new argument exception. Like this. So we expect cards we got blah. Okay, like this. So this will be cards blank. Oh, we got expected like this. Okay, so we have that validated there. And here we can do cards is cards, power is and this is actually bit, right? It's not bit, not power, but bit. So let's change that. Okay. So raw dot split. Raw dot split. Oh, actually that won't work here because I need to pass it as 2 parameters. So we can do a raw dot split like this as to a char array int parse like this, and then we can do actually you want to do this. I call the constructor there. Is there a way to do that easily? Yeah, I can have an overload here to make that work. So I can just do it like this. Parse dot cards parse dot bit. And now we have all the constructors overloaded, and we can actually do this like that. Okay, so now we can go from a single string, call all the constructors, etc. Only thing that we need to do now is actually figure out what kind of hand rank this will be. So this will be, what was it? looks like 5 of a kind, which is funny because that doesn't exist in the real thing. So like this. Let's just dump this above here. Great. So we will need to do a var grouped is cards grouped by x. Yeah, because it's already like that. To dictionary. Like this. We do int max count is grouped max value. Let's see. Actually, isn't this like a so the first one is count of 5, count of 4, count of 3 plus 2, count of just 3, then count 2 plus 2, right? Let's see, 2 pair, count 2, else. Okay, so these are the ranks, right? So we have 1, 2, 3, 4, 5, 6, 7. Int different hand ranks is 7. Let's put that up here as well. Const see. So what I'm thinking is, what I can do here is actually group. What we want to do is actually do this and then just group by count and then see how many there are. So we do group by x dot value to dictionary x key. So now, if I just do this, var by counts is this. So we do if by counts try get value 5 out. We can just do contains key 5. Power. Let's see. No, hand rank it is, right? Hand rank is 7. Int hand rank. Max. How did I call it? Oh, different kind of hand rank. Okay, that is fine. Else. So we can do this. We can decrement hand rank here. If we don't have 5. If we don't have 4, we can also decrement it. no, you need to keep doing this. Maybe the positive is just better. I was just thinking like, is there a way to not hand code everything here? Let me just do it like this. So this will hand rank 7. I thought I could do this in a clever way, but I'm not seeing a very straightforward way without making it very confusing. So let's just not. Let's see. Boom. Hand rank is 6. So if it contains 3 and by counts contains 2, hand rank is 5. Right? Contains key. And these become else ifs. I can actually subnest this. So what I can do is here. If it contains 2, then it's 5. Else hand rank is 4. Then we can check if it contains 2. That is fine, but we also have 2 cases here. Actually, we can do try get value in this case. Out int how many pairs, pair count actually. So this will, pair count is 2. We get 3, otherwise it's 2. Like this. Why doesn't it like this? Ah, okay. Sure. Like this. Fine. And that takes case of those final steps, and else we do, I need to remove this one, else hand rank is 1, basically a high card, right? So this is the everything matched. So let's just set up a test here actually. Now we can just do it actually. Let's just 2 lines, select X, new hand, 5 card hand, 5 card hand, like this, to this. So we do var hands this with this. And we do for each var hand and hands. Console, white line. Let's do this. Hand dot cards. Hand dot bid times hand dot hand rank. Right. And this will probably print out. I wonder if it will do the array or just. I should probably do this. Let's change this to run day 7. Let's pull up the example text here and see what it does. So let's see. Only pair, so it gets rank 1. Oh yeah, I need to order this in strength as well. So I haven't done that yet. But yeah, let's look at this here. Let's put it like this. So at least the numbers are all validly parsed. That is fine. So we have, let's see, 2 pair and 2 pair. Oh no, this is a full house actually, and this is a full house. 3 of a kind. Isn't that a full house? Oh no, T and J, J and A. Okay, 3 of a kinds, the 2 pairs, 1 pair. Okay, so that is parsed correctly as far as I can tell. I should probably just write out tests just in case, and then go on to the sorting thing here. Boom, 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 boom. So let's just write that out here. So we do, I can actually do it in here. Just do public static bool test. Actually, it can be a void because I will throw it if it's wrong. So we do high card. That's far. High card is new 5 card hand. And we'll do 2, 3, 4, 5, 6, 1, 1, 1. High card dot hand rank is not equal to 1. Throw new application exception. Didn't parse high card correctly. Actually, I can just do it like this. You don't need to put it in a variable every time. You can just do it like this. And let's set up all the test cases here. So this one becomes a 2. Let's do 3, 3 actually, and then do 2, 2. And then it's 2, 2, 3, 3. And then it's 4 2s. And it's 5 2s. Alright. Okay. So this one should be 2, 3, 4, 5, 6, 7. High card. 1 pair. 2 pair. 3 of that kind. Full house. 4 of a kind and 5 of a kind. Let's just run this and make sure that our parsing there is correctly. So you do 5 card hand test. Because I want to know it now and not later. That passes, so that is fine. Great. We now are able to distinct between between all the hand ranks, so that is fine. And now we need to actually order those hands. Boom, 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 boom. Do I write an I compare for that? I don't even remember. I compare. Let's just see here. Can I sort these? Sort. Comparison, okay, I compare, sure. Let's see the comparison to, okay. Yeah, let's do an I compare then. Cool. A namespace color delecting. I need to. It's been a while. I need to implement this interface. Okay, so now I can do. Sure. And now I need to implement the interface explicitly. And now I get a bunch of functions that I need to do. Okay, that's not bad. I should probably make it its own object actually. Public class 5 card hand comparer. I compare like this, and then have this, and then it's fine. If, okay, this is fine actually, no. If X is 5 card hand
A and actually I can do if like this. So new argument. We expect both sides of the comparison to be set. Like normally you want to account for nulls and all sorts of that, but this will never happen in our case, so we'll just make sure that we have it parsed out. B like this. So now we can do if A dot hand rank different from B dot hand rank, return A dot hand rank larger B dot hand rank. I need to remember the ordering. 1, 0 like this. Else they are the same, and now we do for int I is 0, I smaller than 5 hand dot expected hand length. Let's make this a public const. I'm allergic to magic numbers, so I try to use them as little as possible. Plus I. And then we do if A dot cards I not equals this, yes, return, and then we compare them. And we need to map this with our dictionary here. So we have a static, let's put that here in the cards. Public static dictionary card map. Let's just uppercase that. So we can do 5 card hand dot card map like this. Oh, I have an issue here. Just need to be 1. At the end here, we can just return null because they are equal. And actually, I can do this. Yeah, this will be the dead part anyway. So that is fine. I think this is actually it already. Let's see. We don't need to test this anymore. I can do hands.sort like this. Right. Why doesn't it like this? This is an eye comparer of, okay. Really? Like this? Oh Jesus, I need to do this explicitly. So now, okay. You get it like this. That is fine, that is fine. So now I can do, if not, x at has value. Okay. A. B. I prefer this. Now what is the issue? A containing type does not implement interface I compare. What? Okay, yes. Like this. Okay. Now we're cooking with fire. So now let's see if the sorting is correctly here. So let's see, we have Q above T, that is fine. Yes, it's all correctly, nice. KK before KT, so yeah, the ordering and sorting, everything is correct. So now we need to, based on their index in the list, need to rank them. So, oh, and I have it in reverse actually, because this one needs to be the first one in the list. So it needs to be low to high. Is there an option to have it reversed? I don't think so, right? I can compare low to high, and I'll call this one high to low. And now I'll just switch all these signs here. So basically what this does, this iCompare, is that it will evaluate this. It will take two values and then it will get like a -1, a 0 or a +1 to know how they should be relative to each other. So it's fairly simple. And I now have it high to low, and this needs to be low to high. Low to high. So now it will print out the lowest one to the highest one. So they want it here. K. The first we have. Second card is stronger, so KT gets rank 2, and then KK gets rank 3, so that is all correct. So it's now the index plus 1 will be its power. So now what we can do is hands.select. Actually no, it's I can do this hands.width indices. Whoa. Select x dot index plus 1 times x dot value dot bid, and this you need to multiply this times each other. Is that dot product? Okay, so that is also fine. Let's just I know, and then we sum these, actually sum. So long result is this. Can I turn everything here into longs just to make sure that we don't go out of range? Okay. So we can do console.writeLine part 1 result. Let's run this. 2190. Oh, that's not correct. Okay, let me see if I do what I do wrong. We're nearly there, so it should be fine. So let's do, whoa. Why is my PC dying all of a sudden? Okay, so var calculated is this. Let's just check out what it says here. Let's see how that compares to this. So we have, let me just scroll down here so that I can get it all into view. 765 times 1 plus 220. Oh, wait. Did I do something wrong here? Oh, precedence, okay. Jesus. Yes, okay. I think that's it actually. So let's do result is now 6440, is that correct? 6440. Okay, so that is correct. Let's run it on the real input. Like this. And let's see what it spits out. That's a big number. Let's see if this works. Woohoo! Part 1 done. We got there. It's not a lot of trouble. It's a lot of implementing, but not a lot of trouble to implement it. So that's a nice start to the problem. So let's see what part 2 holds in store for us. And I'll be curious to see how other people implement this. I usually take like an enterprisey approach with stuff, so I'm curious to see how other people did this. I liked my approach, but woohoo! Gold star in the chat from Smap UK, thank you. Let's continue to part 2. To make things a little more interesting, the elf introduces one additional rule. Now J cards are jokers. Wild cards that can act like whatever card would make the hand the strongest type possible. Okay, let's see. Today is all about implementing rules. No surprises. This one gives me a bit of pause though, but it will probably be alright, I think. Because I wonder if every J, if you take out all the J's and then do the hand count, and like if every J just improves it by 1. I'm looking, because the 3 of a kind case elevates it to 4, so you jump more. So I'll see if I can find a clever way, but I already see some issues. So let's see. But let's first read the entire text and make sure that I don't miss anything else. To act like whatever card would make the hand the strongest type possible. To balance this, J cards are now the weakest individual cards, weaker than even... Okay. So that's for the ordering, so I need a difference in my compare. J card can pretend to be whatever card is the best for the purpose of determining the hand type. I should probably have like a mapping for each base value, what like adding a joker would introduce, like 1, 2, 3, 4, 5, etc. That is probably the easiest. Let's see. J card can pretend to be whatever. Q, JJ will be 4 of a kind, yes. For the purpose of breaking ties between two hands of the same type, J is always treated as J, not a card it's pretending to be. Yeah, okay. So J, KKK is weaker than QQQ because J is weaker than Q. Sure. But also, if that would be, and this is a bit messed up example, if this would be 3, 3, 3, 3, 2, it would still be stronger than J, Q, 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 because in order of precedence, J comes last. So they did a bit of sneaky here, because in the old rules, J was already weaker than Q, but they didn't have an exact example where this ordering comes into play. But yeah, let's see. Now the above example goes very differently. Still one pair, doesn't contain any jokers. Okay. KK is the only 2 pair. T is all 4 of a kind. Rank 3, 4, 5, okay. The new Joker rule, the total winnings are this, okay. So yeah, that's interesting. Because basically I just have to duplicate all my code to account for this new scenario. So I should probably have a logic thing here, like bool use joker rule. That's something that I could do here. And just add it everywhere. That satisfies everything there. Like this. So if use joker rule, else. Basically what I need to do for local cards is cards where x like this. Now we have const card joker is j. What's the problem here? This is a array, so why doesn't it like this? Oh, because I didn't close off the code. Okay, so these are the local cards. And basically this means cards, or actually like this. So now this works on not on cards but on local cards. And it will never hit this case if jokers are used, but that doesn't matter. So now we have our hand rank, and basically we should do a translation that tells us based off of the hand rank without the jokers, based off the hand rank without the jokers to see what the new rank would be. So we do if use joker rule, do int joker count is local card count length minus expected hand length. So these are the amount of jokers. If jokers is 0, actually, yeah, only if we do larger than 0 do we need to do this. Let's see, dictionary int, or is it hand rank? Was that a byte? Yeah, okay. Byte, okay. Hand rank with joker mapping is new. Right? Because if there's a joker, you can reason about what it is. So, like, if you have a high card, your rank becomes 2 because it becomes a 1 pair. High card becomes 1 pair, right? If you have a pair, it becomes 3 of a kind, so it becomes 4, right? So pair becomes 3 of a kind. Then we have 2 pair, that becomes a full house, which becomes 5. 2 pair full house. Let's see, what was 4? This 3 of a kind becomes 4 of a kind becomes 6. 3 of a kind, 4 of a kind. Okay, I think I cut something off here, right? No, I didn't. Fine. And then we have 5 becomes 7 because 4 of a kind. 4 of a kind becomes 5. 5 of a kind.
And this is the mapping for one joker. And basically what we can do is for every starting point just shift this over and execute it once, I think. Because I was thinking like I could do everything from 1 to 5 jokers and have everything parsed out. But basically you can recall this for every time that you have a joker to change your value. I just wonder if it if you go from...
Is it true? So if you have a high card, you add 2 jokers, you go to 3 of a kind. So that is good. You go from 2 and then to 4. So I think that rings true for every situation. So basically what you do is hand rank is actually so you do 4 int I is 0, I smaller than joker count, increment I, and then you do hand rank is hand rank with joker mapping hand rank. Oh, current hand rank. Right, and this one will give you your new hand rank. I think that's how it works. And basically this mapping is, if it's 1 it becomes 2, otherwise it's +2. See, like increment 1, increment 2, increment 2, increment 2, increment 2. So this one basically means if hand rank is 1, 1, 2, right? This is the addition, basically. So you could do, instead of this, you can do plus equals this. It's the same logic. Right? What's the issue here? And I need to make sure that this remains a byte. Right, so we worked out the logic. It's good to write it out, but basically it comes down to if you're starting from hand rank 1, you get 1 added to it. If not, you get 2 added to it, and that for every joker that you have. And I think this is the thing. Oh, okay. False for all of these. And I could make it a default actually, but yeah, that's fine. Oh, we can also actually test out this new logic. Hey, I should have thought of that. So let's see. So now we have J, and we expect with true, we expect this to become 2. With 1 joker. 2, 3, 4, right? J, 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 J. Okay, so 2, then it becomes 4, 5, 7, right? Let's test this out. Oh, and input becomes, okay. For now, let's leave it at not implemented. I want to run my tests. Boom, did it pass high card with, okay, what is the high card, the hand rank now? It's 1. That's interesting. Okay, let's set new statement. Step into this. Boom. Okay, never mind. Set new statement. Step into. Yes, okay. Step out, step in. Okay, like this. Boom. Local cards should now be 4. Ooh. Wait. Use Joker rule. I have this one switched. That is good. See, it's stupid stuff like that that will trip you up. Where did I have the console right line that dumps out all the cards? I also need to just not do that for now. Boom. 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 Okay. Still not correct. Let's see what it does. It still says 1. So, okay, let's see. Let's debug this. Step into. Step over. No. I'll just set my breakpoint here. That's easier. And let's do this. This is very slow, but use Joker rule is true. Conditional debug breakpoints are very slow, just so you know. So now, okay. So let's see. Local cards should be 4 now. Okay, that is 5. Fine. So now the hand rank will still be 1. We have the Joker rule. The Joker count is minus. Okay. I have this the wrong way around. See, all the stupid mistakes that will bite you in the ass. Okay, let's do this. Set next statement. Boom. If it's larger than this, yes. And now hand rank is 2. Okay. Let's run it. Let's delete the breakpoint. Okay. Exceedingly so. I use them with caution. Yeah, I don't use them all. I usually just write code because it's just very slow. And I'll just write like, if my statement is true, system diagnostics the debugger.break. Like to break actually code, or even just put in an empty console.write line and set a breakpoint on that line, and that is a million times faster. But I knew it wouldn't be that bad in this case. Okay, so here go to, I made a mistake. Because it will go from 2 and then to 4. And this will be 6, and after that it will be 7, right? And this is also my last issue. Let's see. Because if you're at 6 already, it should not go over 7. So it will be min, max, and let's see. So this one will take different hand. Okay, Jesus. Different hand ranks, comma this. No, that won't work. Okay, so now it starts to get messy. So in this case, if hand rank is 1 or hand rank is 6, we add 1, otherwise we add 2. Because we never wrote out the case here. Wait a second. We go from here to 2, then to 4, 3 of a kind. Then we go from 3 of a kind to 4 of a kind. Oh, why do I have a missing mapping here, like a hand. Let's see. I don't have the full house in here. So this will be 6. And if I had that, I would have known. So if I did, this one goes to 7. This one be full house. We'll go to 4 of a kind. Yes. So this one goes to 6. Okay, so I'm let's just go back to this, because this is actually the better way to do it. It's cleaner. High card becomes one pair becomes 3 of a kind, 2 pair becomes full house, 3 of a kind becomes 4 of a kind, full house becomes 4 of a kind. So there's no upside to having a 3 of a kind or a full house, and then 4 of a kind becomes 5 of a kind. So yeah, sorry about that. And that's why you do these tests, right? This is very useful. So yeah, 6, 7. I think this is it. 2, 4, 6. Yes. And then we should also add in the other test cases there. Okay. Actually we need to do not the increment, but like this, assignment. Okay, so now all the tests pass, and now we need to add the extra conditions, because we need to be able to hit the 5 as well, and that is what you get from 2 pair. So if you do 2 pair, so we do 2, 2, 3, 3, J, and this one should become 5. 2 pair. This one becomes 2 jokers, 3 jokers, 4 jokers, and I think this is all the scenarios that we will encounter, because everything else will just work the same way, I think. Famous last words, but let's add the latest test. That's also fine. So now we should be able to do that. Only thing that we need to do now is have a comparer. Actually, what I could have done, public bool high to low, get set. So what we can do is I mean, it's cleaner to have it the other way around, but this is also fine. It will just become more confusing, I think. Let's just do it a bit more verbose. If high to low, we do this. Else, return 1 minus 1. And we do the same here. If high to low, we do this. Else, we do the inverse. And now we can do the same for the joker rule, actually. Card map with joker rule. And now it becomes offset. Boom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this. And we can have a bool here. Use joker rule. And this one will determine this part here. Var map is use joker rule 5 card hand dot card map 5 card hand dot card map with joker rule. So now I can just do this without having that implemented, have that all be cluttered up. Okay, so we have everything there. And let's just make these required in the constructor. And we will change the name here. So we do bool high to low is true. obviously the default will be false and bool is false. Okay, so now we do high to low is this and user like that. Okay, now we change the compare. I don't know why I had a brain fart before when that I thought I needed to make more compares. So let's do that. The low to high one can be deleted now. This one will be, and we'll do it like this. High to low is false. Use joker rule true. So I'm really curious to see. This will now become part 2. We can remove the test. I should actually run the test input just in case. Let me just run the test input just to give me some sense of security. 6440, is that correct? No, that's not correct. Jeez. Okay, let's see. Did I enable the... I probably didn't do the constructor on the cards with the joker rule. Yeah, see, I didn't have it enabled here. True. So let's do use joker rule true. So let's set this up as a bool. Bool use joker rule is true. I should probably make this lowercase anyways. But yeah, now at least it's all passed in the correct way. 5, 9, is that correct? Yes, that's correct. Okay, so now let's run the real input. Input like this. Given key 7 was not present in the dictionary. Okay, how is that possible? Let's see, because joker count is 5. Okay, let's see. So the hand here is actually 5 jokers. Okay. Because if you have 5 jokers, you don't have the high card. So what we can do is if joker count is expected hand length, and then we do hand rank is max. What did I call it? It's a great sign when you can't remember the name of your variables every time. So we set it to the max, else like that. Okay. Cool. That's a special case. Boom. Okay. Let's see. Woohoo! Part 2 in the bag. Nice. Yeah, it was a lot of parsing and logic, but I liked the way that I did it. And I was actually smart enough to write some tests this time to make sure I didn't make any stupid mistakes. Because as you saw, I had a bunch of small little errors that would have taken me a lot more time to figure out later on. Smap UK says the 5 jokers caught me out the first time. Yeah, because it's if you have 5 jokers, you actually don't have a hand to start off from. You know where my code is. Yeah, okay, let's see what you've done. Let's see what you've done. github.com/ it's in my history already. Let's see. Solutions 2023, day 7. Let's see. Type, strength, okay. So you have individual strengths there. Let's see. Order by, okay, so that just did a link order by here. This is also fine. I kind of like my my compare this is perfectly fine. Select yes, let's see. A record hand, parsable hand, my parsable jacks, wild hand. Okay, let's see. Cards that any card labeled jack, card labeled is not jack, group by, okay, you group by the card, order by descending in count. Select let's see what you do here. So you group by the cards, you do descending order, but then you select the names, okay? But you lose your count information here. Select first or default, jack. Cards, select. Okay, this is the label, okay. I'm not sure I understand that, I will check later. Let's see, cards, label is jack, card with. Okay, you replace the jack with the one with the highest count. Yeah, okay. Yeah, I figured it out as you wrote it. So you do it like that, okay. Let's see. You have the basic, the same way of doing it, basically. So which card I have the most of? Yeah, got it. I actually never did the replacement because it's just not needed, but it's fine. Why is bid 6? Why do you have this one here? Bid amount as int. I don't get it. Is that the length? No. Cards. So from 0 to, sure. This is the index, okay. Yeah, this didn't read as indexes to me because you have like the amount of cards here. But these are just indexes that you use for parsing. Yeah. Yep, I see it now. I still have not used like spread operators in C# like that. Do you prefer writing it like that over a substring? This takes me more time to process what's going on here. Sure. Okay, this is funny. So you just made a strength property. No. Sure, nice. Okay, I think that's it for today. I hope you liked the stream, had a bit of fun. I had fun coding it. So yeah, curious to see what day 8 holds. I'm glad it wasn't too complicated today because I think Advent of Code started off pretty spicy, and this was right on track for complexity in my book at least. Let's see, Smap UK says, it just seems odd as it's new to a lot of people, but I've been using it since I came into the language. Okay. Sure. I'm used to seeing it in Python, like the spreads and the ranges. I'm just not used to seeing it in C#, and like when you use it to substring and you have all those variables in there, it becomes a bit messy, I think, at least. And well, it's fine because it's a fixed length thing. I think the thing that I use isn't that much more readable, so I just split it by line, and then I have my constructor here that takes the space as a splitter and then parses it out. So yeah, to each their own. It's all fine. It's just something that I need to get used to, and something that I just can't get into my system is like the switching, like the inline switch, like the expression filtering. I still need to do that more. Yeah, I like today's challenge. It's been fun. So thank you everybody for keeping me company, and hopefully see you tomorrow. Bye bye.